Alright, we would talk about base multiplications as we are used in Vedic math. This is video number 4. It's a fourth video in the series, and I'm Sarwan Agrawal. Let's continue. We'll go over a brief outline here. In this section, we would try to compare with the conventional math a base multiplication with conventional math. We'll do a multiplication in conventional math and also using the Vedic math way. Let's talk about here some special multiplications. There are some special multiplications in conventional math also, like 37 times 100, 53 times 10, like 79 times 1, and these are special, and student doesn't have to work on these multiplications, can get the answers right away. And answers are 53 times 10 is 530, add a 0 to the right. 37 times 100, add 2 zeros to the right, 3700. 79 times 1 is 79. Multiplication by 1 does not change the result. It gets same result as the number being multiplied is. Okay, let's see what we can do in Vedic. In the Vedic math, we can do all that and many more, like we can do 37 times 99 in addition to 37 times 100. We can do 98 times 99 in a special way. 53 times 85, like 63 times 99, 37 times 9, and many more. 89 times 999, and okay, let's do base multiplications as they are done in Vedic math. In these multiplications, at least one operand is close to a base number, and we prefer natural base number. Sometimes we use proportional base numbers also. Okay, let's take an example. We're going to take example of 998 times 817, and you know the drill. On the conventional math, we take rightmost digit of the multiplier, multiply that with 998, the multiplicand, write the answer. This is intermediate product. The next intermediate product is take the one next digit of the multiplier, multiply with 998, and we write 998 shifted to the left by 1. Then we do the next digit 8, multiply that with same multiplicand here, get 7984, and shift that again by one more place to the left. So we have three intermediate products. Then we add them all together to get an answer of 815366. So we did 998 times 817. We start multiplying 9898 with the digits in the multiplier in each of these intermediate products on separate lines, and shifted the second line shifted by 1 to the left and third line shifted by 2 to the right, and then add them together to get 815366. Let's do the Vedic math way. In Vedic math way, we write the two number just like we did before, 998 817 on two different rows. Okay, now we look at base numbers here. 998 is very close to a base number of 1000, and that's the base we are going to use. So we write on base how we write the base. Base number is 1000, and we write down on the above these numbers we are trying to multiply. Okay, next we are going to compute deviations. Deviations of the two numbers we have from the base number 1000. So let's see how we define deviation. So we deviation 1, I'm going to say 998 minus 1000 is minus 002. So it's a number minus the base is my deviation. Negative number sign I'm going to use for operation here. So I'm going to use to subtract two numbers. 002 has three digits, 1000 has three zeros to the right, and we try to keep it three digits in the deviations. Okay, so minus the next deviation I compute from 817. 817 minus 1000. Next number minus base is minus 183. Okay. So we get a minus 183 here. Then next we do is ready to multiply now. Okay, we multiply in two parts, left and right. Okay, on left we apply crosswise. What do we apply? We apply the operation minus on the two numbers 817 and 002. So we do 817 minus 002. 817 we apply crosswise. 817 minus 002 is 815. Mathematical correct term would be add the deviation 1 to the number second number. That would be 817 plus minus 002. And some people, the confusion would come in, hey, are we subtracting? I just say use the apply crosswise here, which is we're going to apply 8, do the crosswise here, 817, then negatives minus, and then 002. So we apply operator minus subtraction between on two numbers 817 and 002. You could get same 815 by 998 minus 183, but I find 817 minus 002 a lot easier to do, so I use 817 minus 002. So on the right we multiply vertically, minus 002 times minus 183. Okay, so right multiply vertically, minus 002 minus 183 is negative signs cancels out, 366. Okay, so we have a on left 815 and on right 366. Number of digits on the right 3, number on the right is positive, and we can say that answer is 815 366. But another way to do is to say that answer is left times the base plus the right. Okay, so we can say left times base plus right, which is 815 times 1000 plus 366, 815 366. Sometimes this detail would come in handy when the number of digits on the right is not equal to number of zeros in the base, or uh, right part is not positive. So in those cases, this detail would really come in handy. All right, I can do some exercises now, like 996 times 995, 97 times 98, 997 times 998, and some more. To next section now. Next section, we're going to talk about examples of various cases. We just did one case here where both of the operands were less than the chosen base number. So we'll do some more examples here. Let's see what's and apply the same formulas. So example 1 is 1003 times 1002, where both numbers are more than the base number. Let's choose the base number first. So base number is 1000. 1003 is more than 1000, and so is 1002. Okay. Okay, now we are going to compute deviation. Deviation 1 is plus 003. 1003 minus 1000 is 003 and is positive, so we use positive, and then 3 zeros here on the base. We try to use 3 digits on the deviation. That kind of gives me a hint that I do need 3 digits in the right part. Okay. Deviation 2 now is 002, and okay, and now let's look at left part. Left part is cross apply. We apply 1002 plus 003, or 1003 plus 002, which is 1005. So we 1005 goes on the left, and right multiply on the right. We multiply vertically. 003 times 002 is, with plus signs, is 006, and we need 3 zeros here. We need 3 digits here. Students would generally have issue here, would forget number of digits required on the right side. So that's one of the issue errors here, situation where the students mess up every now and then. Okay, so It's a practice, practice, and practice. Review the slide and practice. Let's go do another example here. So answer is 1005,006 here. Okay? 1005,006. When the number of digits on the right is equal to number of zeros in the base and right part is positive, we don't have to base times the left part plus the right part. We can just say two numbers together. Left is 1005, right is 006, and the answer is 1005,006. Okay, let's do another example. Example 2 here. In this case, we will have 1243 times 98. 1243 times 98. 98 is very close to base number of 100, and 1243 is way off. So we choose a base number of 100. We are choosing base number 100 so that this is the number that's close to 98. And now we start to compute deviations here. Deviation 1 is 1243 minus 100. It is plus 1143. It's plus. 1243 is more than minus 100. So 1143. Deviation 2 is 98 minus 100 is minus 02. Okay. All right. Now let's see what to do on left. On left, we do this crosswise apply. 1243 minus 00 minus 02. We apply minus on the two operands 1243 and 02. You could do same thing on the right. 98 plus 1143 are apply plus on the two operands 98 and 1143. You get a 1241 either way. Okay. On the right, we multiply vertically. It's a minus 2286 plus 1143 and a minus 02 multiplied together. We get a minus 2286. So on the left, we had example of both numbers were more than the base number, plus in deviations. On the right, we have a case of first number is more than the deviation of 100 and second number is less than the base number and was negative and a positive. Okay? And the answer in this case I better do base times. So minus 2286 go on the right. This is a negative number and it doesn't have a two digits, the required two digits. So we would do a 1241 times base and minus 2286. So we do left times 100 plus right, and which is 1241 times 100, 1241 and minus 2286 is 12. Let's look at steps used in the multiplication, base multiplication. First, we find a base. Second, find deviations, which is a subtract operation. Then determine left by cross applying, which is add or subtract. Okay, then determine the right by vertically multiplying. This is the only multiply we do, and deviations are usually small, and this multiplication is easy. Okay. And for proportional base, apply that proportionality to left. So if we had a base of 2 times natural base, then we would say 2 times of the left. Then match number of zeros of number of digits on right to number of zeros in the base. Either pad with zeros or carry some digits to the left. Then answer is left right. After we match the number of digits on right, answer is left right. That's it. That's all, folks. These 7 steps and you got it. Okay, let's do some exercises now. You can do 98 times 89, 1003 times 1015. So here the deviations were both negative, and here the deviations are both positive. So with 1003 times 990, a positive deviation for the first operand, and second operand it's a negative deviation, and some more. And 578 times 998, and 995 times 986, and some more. Okay, let's do some more examples. This time we will use base of 10. Last time we used the larger bases. So numbers we are trying to multiply 17 by 13, and base we decided to use 10. So base is 10. Let's find deviations now. First deviation plus 7. Next deviation plus 3. 17 minus 10 is plus 7, and 13 minus 10 is plus 3. Now on the left, we're going to cross apply either 17 plus 3, which is 20, or 13 plus 7, which is also 20. So we use 13 plus 7 here, 13 plus 7 is 20. And the right, we would do a vertically multiply 7 and a 3. Plus 7 times plus 3 is 21. So 7 times 3 is 21. Okay. And answer is left times base plus 21 is 221. So 17 times 13 is 221. Okay, let's do another way. Also right is 21. The two digits, we only need one. This 2 need to be carried to the left. Okay. So we would carry this 2 to the left, and that would make it a left become 20 plus 2, which is 22. Answer is now 22 from the left and 1 from right. 22, 221. Answer is 221. Okay. Let's do another example here. This time we will do 12 times 18, and base we are going to use 10. Okay. Deviations now. First deviation, 12 minus 10 is 2. Next deviation, 18 minus 10 is plus 8. Now we will do a left, which is cross applying. So we did 18 plus 2 is 20, and similarly 12 plus here plus 8 is also 20. So we got 20 on left. On the right, we would do a vertically multiply plus 2 times plus 8, that's 16. Okay. Now answer is again left times base 20 plus 16, 216, and also 16 has two digits. Number of zeros on the base is 1. We only need one digit on the right, so this one get carried to the left. So when you carry 20 plus left becomes 20 plus 1, 21, and the answer is 216. 21 from left and 6 from the right, 216. Okay. We use base of 10 to extend multiplication table. So we try to, if you knew only tables until 10 by 10, we can extend that using the base of 10 we just did. We found out 17 times 13 and also 12 times 18, and you can do 11 times 15. Let's go next section here. Next section is would develop this method we just used. Will prove that the method we use has a basis. Okay, let's do the method we just used. Recall that deviation is number minus base. So to compute deviation, we say we subtracted base number from the given number. Number is from that number must be base plus deviation. We need two operands. One is multiplicand and other is multiplier. Let's continue the method. Let n1 be the multiplicand. We decided we need two operands. One is multiplicand. We use n1, the first operand, as multiplicand, and 2, the second operand, the multiplier. Then x is the base. That's the variable x in algebra. That's x be the base. Okay. And then a1 is n1 minus x. We say deviation 1 is number minus the base, deviation 1. a2 is the deviation 2 is n2 minus x is deviation 2, which is number minus base. Okay. That means n1 is from here is equal to x plus a1 and n2 is x plus a2. From this equation here, n1 is x plus a1 and n2 from this equation is x plus a2. Okay, let's continue with the development. We know that we had already established that n1 is x plus a1 and n2 is x plus a2, and we need to multiply the two numbers. So we do n1 times n2. n1 is x plus a1, so x plus a1 times n2 is x plus a2, x plus a2. So we have n1 times n2 is x plus a1 times x plus a2. Okay, and which is equal to x squared plus x times a1 plus a2 and plus the constant term a1 a2. You can use a vertical and cross multiply to of x plus a1 times x plus a2 to arrive at x squared plus x times a1 plus a2 and plus the constant term a1 a2, and which is equal to, we just factor out x from the first two terms here. From first term we got other factor is x, from next term the other factor is a1 plus a2 and plus the constant term. Okay, let's go regroup this thing. If we combine x and a1 like x plus a1, this is n1. So we have x times n1 plus a2, okay, and the constant term. Okay, that's x plus a1, that's x times n1 plus a2, and this is our left term which computing. Apply crosswise the definite deviation. So n1 was first operand, n2 was the second deviation. So we apply second deviation n1 plus a2, and that's what okay, and that's this is left thing we have been doing so far. Okay, again if we regroup it, so combine a2 with x, so and x a1 here, so x plus a2 is n2, n2 plus a1 here, okay, and the constant term here, okay, and so x times n2 plus a1 or plus a1 a2, the constant term. Okay, so all right, let's continue. We already know that n1 times n2 is equal to x times n1 plus a2 plus the constant term we just established on the previous slide, and also is equal to x times n2 plus a1 plus the constant term a1 a2. Okay, and which is x times left plus right, and that's what we have been using, and we just derive the formula we just have been using. Okay, all right, let's take example here. Example is n1 is 1015 and n2 is 1003, and let's compute deviations now. Base is 1000, a1 is first deviation 015, second deviation a2 is plus 003, and left is n1 plus a2. N1 is 1015 and a2 is 3. 1015 plus 003 is 1018. Okay, and right is a1 times a2 is 015 is times 003 is 045. A number of digits in the right is 3, number of zeros in the base are 3, so we can say answer is 1018045, left followed by the right, 1018045, and you can also do the extra step we have been doing. Okay, extra step is answer is left times base plus the right part, 1018 times 1000 plus 45, it is again 1018045. Okay, okay, let's go next section now. Next section is we will use a proportionality. A random base number here just to satisfy your curiosity. Okay, question, can I use a base other than natural base number? Sure, you can do it. It's Vedic math, it's very flexible. Okay, in fact you can use any number for base number, and we would use a random number, but in Vedic math the mantra is short and sweet, one line mental solution when possible. Okay, let's go continue. In that spirit, our first preference is natural base numbers, and the second preference is proportional base numbers. Okay, let's continue here. To satisfy your curiosity, we will consider a example of 97 times 98, and first thing we do is select a base number, and we would use a base number 95. It's close to these two numbers, but it's not a natural base number. So let's continue. So we have 97, 98, we know base number is 95. Now we go to compute my deviations now. Okay, 97 minus 95 is plus 2. 98 minus 95 is plus 3. So we got two deviations. Now we go to determine left, which is a crosswise. Apply crosswise. What we are going to apply? The plus. Operands are 97 and 3. And we are doing 97 plus 3, which is equal to 100. Okay. On the right, we would multiply vertically 2 times plus 2 times plus 3, which is 6. Okay. 2 times 3 is 6. Okay. Now compute the answer. Okay. It's not natural base number, and we don't know how many digits we need here because it's not. Okay. We would have to use the formula, which is base times left plus the right. Okay. Answer is 95, which is a base times left plus 6 is 9506. Okay, you have it now. We use a base 95, which is a random base number, which has nothing to do with the natural base number or a proportional base number. And we were still able to compute 97 times 98 equals 9506 using a base number of 95. Okay, let's continue. So it's we use a base times left plus right. Continue and consider a proportional base number. Let's see what that is. A proportional base number. These numbers are proportional to the natural base numbers. Thus, we can obtain 30 from 3 times 10, 250 from 1000 divided by 4. This is a sub-proportional, and 60 from 10 times 6, and so on. So we can. Proportional base numbers are proportional to the natural base number, and we'll use the sutra proportionality here. Okay, let's continue. Let's consider example 36 times 33. Here, let's see what base number we use. So with 36, 33, now we're going to choose a base. The base number we choose is 30 equal 3 times 10. We obtain 30 from 3 times 10. 10 has a 1 0 on the right, so we would be allowed to keep one digit on the right. Okay, let's do the base number now. Now we go to compute deviations. Deviation 1 is 36 minus 30 equals 6, and deviation 2 is 3. 33 minus 30 is 3. So these are my deviations 6 and 3. On left, we got to apply crosswise. What we're going to apply? The operator plus between 33 and 6. 33 plus 6 is 39, and so is 36 plus 3 is 39. So on left is 33 plus 6, 39, and right is plus 6 times plus 3 is 18. So we have 39, 18. Now 18 has 2 digits on the right, and we only can have a 1 digit on right. Okay, continue. So 1 is a carry. Carry gets carried to the left. So answer on the left is 3 times 39. So we have to resolve proportionality first. 3 times 39 is 117. Okay, then we would carry this, use the carry here. So we need to resolve proportionality first before you resolve carry. So 117 on left plus 1 more, 118, and then 8 on the right. 1188. Okay, let's continue here. Another example, 36 times 33 again. Okay, and the base number is 40. This time we'll use a base number of 40, which I get from 4 times 10. Tirthaji called this a working base. So its working base is 40, which is 4 times 10. Okay, now we go to compute deviations. Deviation 1, 36 minus 40 is minus 4. Deviation 2, 33 minus 40 is minus 7. Okay, on left, apply crosswise. 33, what we're going to apply? Minus. On the operands, 33 and 4. So it's 33 minus the operand here, minus 4. 33 minus 4 is 29. On the right, multiply vertically. Minus 4 times minus 7, which is 28. Okay, and we only need 1 digit on the right. Okay, so answer is, this time we'll say 20. We would use the formula here. What we say, left times the base plus 28. 29 times 40, which is base, plus 28 is 1160, plus 28 is 1188, the same number we got before. And if you want to do the other way, say 29 times 4 is 116, and 2 get carried from the right. So 116 plus 2 from right, 118. Its answer is 118 on the left and 8 on the right. One same answer. Okay. Some examples now. First example, 203 times 187. We will choose a base first. Base is 200, is 2 times 100, which is a working base is 200, which I got from 2 times 100. We don't have to do the lines all the time. We should be able to do the multiplication. We know the steps. Okay, next, division 1. 203 minus 200, which is plus 3. Okay, 203 minus 200 is plus 3. With division 2, 187 minus 200 is minus 13. Okay, we're going to cross apply. We're going to cross apply first deviation with the first number with the second deviation. Okay, and the operation is negative. 203 minus 13, which is 190. Okay, right is 3 times minus 13 is minus 39. Okay, answer is base times left plus right. Okay, base times 190 times 200 minus 39. It is 38000 minus 39. It is equal to 37961. Okay, also on the right we have 100 minus 39, which is add 100, subtract 100. 100 minus 39 is 61, and minus 100. So this is minus 100 here plus 61. Okay, let's do we have to resolve the proportionality also on left. Okay, left is 2 times 190. Proportionality is 2 right here. Number was 190 on left. 2 times 190, 380. Okay, now this one negative gets carried to the left. Answer is 380 minus 1 from the carry and 61 on the right. Okay, and which is equal to 37961, same number we had before. Okay, let's continue. Another example here. Example this time we'll take 3123 times 2998. Choose a base. Base is 3000, which is 3 times 1000. So working base in this case is 3000, which I got from 3 times 1000. Now the deviations. Okay, deviation 1. 3121 minus 3000 is plus 123. Okay, division 2. 2998 minus 3000, which is minus 002. I'm trying to keep it 3 digits on the right. Okay, so instead of saying minus 2, I say minus 002. That's a reminder that I need a 3 digits on the right. Okay. Left is cross apply. So we did a 3123, which is a first number here, and second deviation. What we do, apply negative, minus 3123 minus 002. I read this number like this: 3123 minus 002, which is 3121. On the right, resolve proportionality first. Okay, left is 3 times 1000. 3 times 3123 is 9363. Okay, and on right, it's a 123 plus minus 002, which is minus 246, and which is, after resolving the negatives, adding 1000 and subtracting 1000, I get negative 1000 and 754. Okay, answer is 936. One negative get carried to left, become 9362, and 754 from right. Answer is 9362754. So 3123 times 2998 is 9362754. Only multiplication we did was this multiplication. Okay, on the right, 123 times minus 002, which is easy. To 123 times 2 is 246, and sign negative sign here. And on the left we did this subtraction here, 3123 minus 002. So we were able to compute this multiplication with just this multiplication here, with small multiplication. On the left we did this subtraction. Okay, do some examples, more examples here. Example is 251 times 252. Okay, so the base is 250. How we get a base from? Dividing 1000 by 4. So working base is 250, which I got from dividing 1000 by 4. Okay, let's continue. Deviation 1 is plus 1. 251 minus 250 is plus 1. Deviation 2 is plus 2. 252 minus 250 is plus 2. Okay. Now the left part. Left is crosswise. 251 first operand and second deviation, and the sign is plus. 251 plus 2 is 253. Right is vertically multiply. Plus 1 times 2 is equal to 2. So that's the only multiply we did. 1 times 2 equal 2 on the right. Okay, now we go to resolve. We do a base times left plus right. Okay, base is 1000 divided by 4, which is 1000 divided by 4 times 253 plus 2. 253 was left. This is the base here. So which is 253,000 divided by 4 plus 2. Okay, which is 63250 plus 2 equals 63252. Okay? So we were able to compute 251 times 252. Only multiplication we did was this one, or maybe if you want to call this a multiplication, adding 3 zeros to 253, that was, and then we divided 4. Okay, all right, so that's what we did. Okay, now let's another example here. 57 times 56. We take base of 50 and we're going to get the base from 100 divided by 2. I could have gotten the base from 10 times 5 also, but I chose this base to get from 100 divided by 2. So my working base is 50, which I get by dividing 100 by 2. Okay, let's continue. Deviation 1. 57 minus 50 is plus 7. Deviation 2. 56 minus 50 is plus 6. Now on left, apply crosswise. So what do you do? 57 first operand and second deviation. Operation is plus. 57 plus 6 is 63. Okay, on the right, we multiply vertically. Plus 7 times plus 6 is plus 42. Okay. Now, answer is base time left plus right. Okay. So on the left is 63. 63 times 100 divided by 2 plus 42. Okay, that's 6300 divided by 2 plus 42, which is 3150 plus 42, okay, which is 3192. Okay, I go through so many steps here, and you should be able to do with practice mentally, and would have to you can skip most of the steps, or let's call it you will be able to combine the steps mentally. Okay. All right, let's do some exercises now. You can do 48 times 52, 73 times 77, 2010 times 1998, 3024 times 3012, and some more. Okay, let's go on to next section now. Next section is we'll study square of numbers ending in 5. So we'll take a number ending in 5 and do the squares. Okay, let's see how it works. Okay, let's continue with the square of numbers ending in 5. First example is 15 times 15, square of 15. 15 ends in 5. Okay, let's continue. Find my base I'm going to use is 10. Okay, let's take another example now. Next example is 45 squared, 45 times 45, and our base is 40. I'm going to choose a base of 40. Another example here is 115 times 115, square of 115, and in 5. Two digits on left are 11, and the base number is, we choose a base of 110, which I got from 11 times 10. Okay, this is 4 times 10, this is 1 times 10. Okay, let's continue. But next we do is find deviations. So it's 15 minus 10 is 5. 45 minus 40 is 5. 115 minus 110 is 5. Is 5 plus 5 all the way. Okay. So here's my deviation 5, 5 plus 5 plus 5 plus 5 and plus 5. Now we're going to find a left by cross applying the deviations. So we can do 15 plus 5, 45 plus 5, 115 plus 5. Let's go do deviations. Left is cross apply the deviations now, which get 20, 50, 120. This is a proportional base. This is natural base. This is a proportional base. So we resolve proportionality now. 20 times 1 is 20. 50 times 4 is 200. 120 times 11 is 1320. Continue. Okay, so these are my, after resolving my proportionality, on left I have a 20, 200, 1320. Okay, let's continue. Multiply vertical on the right, which is plus 5 times plus 5, 25 here, 25 here, 25 here. Okay, let's continue. So we get 25, 25, and 25. Now, notice that we have 25 all the way. Okay, 25 on the right, 25 on the right, 25 on the right. Okay, and 0 on the left. Left number ends in 0, left number ends in 0, left number ends in 0. Another thing is that 25 here, only one digit is allowed. The 2 from 25 get carried to the left, 2 get carried to the left, 2 gets carried to the left. This 2 would slide right into this 0, this 2 would slide into this 0, and this 2 would slide into this 0. Okay, let's continue. So 2 slides into 0 on the left. Answers are 225, 2025, and 13225. Okay, let's continue. Answers are 225, 2025, 1325. So 25 on the right, 25 on the right, 25 on the right. It's 2 here. 2 is equal to 1 times 2. This 20 here is equal to 4 times 5. This 132 here is 11 times 12. So on left part, we have been doing by 1 more than 1 before. It was 1 here, it's 1 times 2. It's 4 here, 4 times 5. Here's 11 here, 11 times 12. Okay, let's continue. On left of 25, we had 2, 1 times 2, 20, 4 times 5, and 132 equals 11 times 12. And that's by 1 more than 1 before. Okay? Now let's do some examples of squares of numbers ending in 5. Okay, let's go. First example is 65 times 65, which is 65 squared. On left, it's by 1 more than 1 before. 6 times 7 is 42 on left, and 25 is on the right. 5 times 5. Okay, answer is 6 times 7 is 42, and right part is 5 times 5 is 25. Answer is 4225. 65 times 65 is 4225. Let's another example here. 25 times 25. On left is 2 times 3, and right is 25. So 25, 2 times 3 is 6, right is 25. Answer is 625. Another example, 0.125 times 0.125 is 12 times 13 on left, 156, 25 on the right. It's 15625, and I need to have 3 digits after decimal, and first 3 digits after decimal here. So on the right, so we would need a 6 digit after decimal. So for that we would get 0.015625. So answer is 12 times 13, 156, and 25. Answer is 0.015625. So extra 0 we added because we need a 6 digits after the decimal. So right now this is 1/8, this is 1/8, 1/8 divided times 1/8 is 164. So we just computed 1/64 is equal to 0.015625. Continue. 155 times 155. Another example here. Left by 1 more than 1 before. 15 times 16 is 240 on left. Right is 25. 5 times 5, 24025. Okay, let's continue some examples here. Digits on right add to base number, and digits on left match. Okay, let's see what I mean. 11 times 19. 1 plus 9 on the right add up to 10, which is base number, and 1 on left match. Okay, let's do by base numbers. Base equal to 10. Okay, and then what do we do? Compute deviation. Deviation 1 is plus 1. 11 minus 10 is plus 1. Deviation 2 is 19 minus 10 plus 9. Okay, on compute left by cross applying. 11 plus 9 are 19 plus 1 is 20. Okay, on the right, vertically multiply the deviations 1 and a 9, which is 9. Base is 10. Number of zeros is 1. Number of digits allowed on the right is 1, and 9 has a 1 digit. So answer is 209. Okay, and also you can do 10. Base times left plus 9. 10 times 20 plus 9 is 209. Okay, let's see. 209 is like 2 and a 09, where 2 comes from 1 times 2. What is 1 times 2? By 1 more than before. A 09 comes from 1 times 9. 1 times 9 is only 1 digit, but we have a 09 here because this 2 on the left is like a 200, which is, and to that the 2 digits on the right. 200 come from 10 times 20, just like here. Okay, so when there's only 1 digit comes on the right, and then you need For multiplication, you actually needed 2 digits and 09 comes in here. Okay. So let's see what happens. On left, it's by 1 more than before. 1 times 2. On the right, it's multiplication right digits with the padded with 0 here. Okay. Let's do some examples. Okay. 33 times 37 is on left 3 times 4 equal 12. On right 3 times 7 is 21. Answer is 1221. Okay. Example 56 times 54. On the left it's 5 times 6 is 30. On the right 6 times 4 24. Answer is 3024. Example 225 times 275. Here the two digits on the right 25 and 75 add to 100, which is a base number. Okay, so on left is 2 times 3 equals 6. Right is 25 times 75, which is equal to 25 times 25 times 3, and 25 times 25 is 625. We just did it recently, and times 3 is 3 times 6 is 18, and 3 times 25 is 75, 1875. So 6 on the left and 1875 on the right. So answer is 6187. Okay, now we can do some problems here. Let's try this problem. 75 times 75, 71 times 79, 72 times 78. Again here, 1 times 9 is only one digit. You would need to pad that with 0. It's 09 on the right. 0.25 times 0.25. Similarly here, 0.21 times 0.21. 1 times 9 is one digit. Okay, so we have to watch out. Okay, and some more. 125 times 125. 3.1 times 3.9 and so on. Okay, we are next section here. The next section is multiply by sequence of nines. Okay, let's consider multiplication by sequence of nines. We would let's take example here. Example is 347 times 999. Multiplier has all nines. It's sequence of 9. Okay, so we write down two numbers for base number multiplications. Now we go to find a base. Base is 1000. 1000 is close to 999, and that's what we would use for a base. Okay, let's continue. So now we need to compute deviations. Okay, first deviation. Deviation 1 is 347 minus 1000 equals minus 653. You can compute 653 by using all from 9 and last from 10 of 347. Okay, let's go continue. That's 999. Deviation 2 is minus 001. Which same thing, you can do a all from 9 and last from 10 to compute 001 and minus sign because it's a we're doing subtraction of larger number from the smaller number. Okay, let's continue. Now we're going to do a left, compute left, which is cross applied deviation. So we do 347 minus 001. What do we do? Apply the operation minus on the operands 347 and 001 to do 347 minus 001, which is 346. Okay. Now we go to on the right. On the right, we get to multiply vertically the deviations. Okay, so right, multiply vertically, which is minus 653 times minus 001, which is 653. Okay. All right, so the answer is 3. Okay, base is 1000. 1000 has 3 zeros. Right has 3 digits, all positive, and answer is 346653. Okay. Continue. Answer is 346653. Left part of the answer and right part of the answer. Okay. Let's continue. Let's do observation. Left part is 346. Right part is 653. Okay. Let's do this part 346 and 653. Okay. So left part plus right part. Let's add them together. 346 plus 653 is 999. 346 left and right are 9's complement of each other. So 346 plus 653 is 999. Let's continue further. And first operand, which is 347, plus the right part, 653 is 347 plus 653 is 1000. That means the 653 is all from 9 and last from 10 of 347. Okay, let's continue. So left part is first operand minus 1. So that was it. Left operand is 346 and first operand was 347. So left part of the answer is first operand minus 1. Investigate further. Example was 347 times 999. Okay. By addition and subtractions, we can do 999 is 999 plus 1 minus 1, which is 1000 minus 1. Okay, let's continue. So it is 347 times 1000 minus 1. Okay, and which is equal to 347000 minus 347, which is, we would do all from 9 last from 10 of 347 is 653. We'll do 1 less than before of 347. So it's a 346653. Okay, this is by sutra. Again, 1000 minus 1 is 1000 plus negative 1, which is 1001 and negative 1. Okay, all right. Expression become 347 times 100 and 1 negative. Okay, all right. That's 3. So 347 positive and 347 negative, which is again 346653. All from 9 and last from 10 of 347653 and 1 less than before of 347, which is 346. Okay, let's continue. Now let's investigate rules. We're just going to look at the case we just studied. Number of digits in multiplicand is equal to number of nines in the multiplier. So we had 3 digits in the multiplicand and 3 in the multiplier. Okay, for that case, left part is 1 less than before of the multiplicand. Okay? And right part is all from 9 and last from 10 of multiplicand. Okay? Computing recurring number requires such multiplications. Okay, so its application is in recurring numbers computation and maybe in astronomy also. So example, for recurrent numbers, we say 1 over 7, and if multiply by 143 in the numerator and denominator, so it become 1 times 143 divided by 7 times 143. Then further multiply by 999 on the numerator and denominator. So that's what we got. So in the numerator we had to do 143 times 999. Okay. In the denominator we get to do something a lot easier. Okay. So in numerator we have 143 times 999, which is a on left part it is 1 less than before of 143, so 142. On the right it's a all from 9 and last from 10 of 143, which is 857. So we just got on the numerator of 1 over 7 after 143 times 999 is 142857. In the denominator we have 7 times 143, which is 1001 times 999, and which is sequence of all nines. Okay, so we have a new 1 over 7 is numerator of 6 digits divided by a sequence of 6 nines, okay, which is a fractional representation of a recurring number. So recurring number equivalent of 1 over 7 is 0.142857 recurring. Okay, let's continue. So 1 over 7 is 0.142857 recurring. Let's continue. We got a multiplier 143 from a subsutra. It also comes from 7 is a factor of 1001, and we can get a sequence of 9s from 1001 because we got had a 1001 means 1 sandwiching a number of zeros. A form of this type 1 sandwiching a number of zeros, I can get a sequence of 9 by multiplying by sequence of 9s, and number of 9s in a sequence is 1 more than number of zeros. Okay, so let's continue. We'll do a case number 2. Number of digits multiplicand is less than number of 9s in the multiplier. So sequence of 9 is longer. Okay, let's continue. Take example. In this case, prepend multiplicand by adding zeros to the left. Okay, so we'll make them equal. So we'll use that in 1 over 13. So if you're trying to do recurring numbers for 1 over 13, steps are we multiply both the numerator and denominator by 77 first, so 77. Then we multiply both the numerator and denominator by 999. So in the numerator we have 77 times 999, which we change that to 077999. In the denominator, so we have a numerator is 076923, 1 less than before on the left, and all from 9 and last from 10 on the right. Okay, let's see. In denominator it's 1001 times 999 is a sequence of 6 nines. Okay, So 1 over 13 reckoning number is for equivalent is 0.076923. So 6 digits divided by a sequence of 6 nines is a fractional equivalent of a reckoning number, and reckoning number is 0.076923. Okay, continue. Another case here, which case 3, number of digits in multiplicand is more than number of nines in multiplier. So sequence of 9 has a smaller length. Okay, let's look at example. 4689 times 999, 4 digits multiplied by sequence of 3 nines. Okay, let's do that using base numbers. So use a base of, first we select a base number which is 1000. We select it from 999. Okay, so it's 1000 is close to 999. Okay, let's continue. So division 1 is plus 3689, which is 4689 minus 1000 is plus 3689. Division 2 is minus 001, which is 999 minus 1000 is minus 001. The 1000 has 3 zeros, and I will try to keep 3 digits in the deviation. Okay, I know there are 4 here on the first division. But here when I could use a fewer digits, I'm trying to use 3. Okay? Let's continue. So first we do a cross apply the deviation and to get left, which is 4689 first operand and second deviation, and we are going to use operation of minus. Okay, so it's a 4689 minus 001 0, and that's 4688. So on the right, on the left we have 4688 so far. Okay, let's continue. Do the right, vertically multiply the deviation, so it's a 3689 and minus 001, and that become a minus 3689. There are two issues with this thing on the right part. First, there are 4 digits here. When I only need 3, uh, because 1000 has 3 zeros, that's a base. And other issue is it is negative, and I use a positive number on the right. So let's resolve those issues here. So if I was minus 3689, if I add 10,000 to it and subtract 10,000, I get a negative 10,000 and 6,311. So it's negative 1, 6,311. So last 3 digits are positive. We'll keep them on the right, and the left 2 digits, one negative, one positive, will move to use as a carry to the left. Okay, let's after the carry we have 4688 plus 1 negative 6. 6 plus 4688 is 4694, and then subtract 10 because the negative 10 here become 4684. After the carry, left become 4684, and the right is 311, and answer is 4684311. Okay, let's continue. So answer is 4684, 4684 from left and 311 from right. 4684311. Okay, let's continue. And also you could do that 4689 times 1000 minus 1. Okay, 999 is 1000 minus 1, which become 4689000 minus 4689, which is 4684311. Okay, when number of digits in the multiplicand is more than sequence of 9 digits in, when multiplicand is longer than the sequence of nines, this is probably your best bet. Okay, that you convert that nines into a base number minus 1 and do this multiplication. And you can go ahead and do that to use the base multiplication, but this probably is your easiest thing. Okay, okay. Let's problems here. Let's try 37607 times a sequence of 5 nines, 87079 sequence of 4 nines, 52195 times sequence of 6 nines, and some more. Let's continue with next section here. Next section is the different base numbers. We would have a multiplicand and multipliers are close to a base number, but the two numbers are base numbers are different. Okay, let's continue. Near a different base number, let's see what's doing here. So example we do is current 9998 times 105. 105 is close to base 100 and 9998 is close to base of 10,000. Okay, the two different base numbers. Let's see what we do here. We would use by multiplication and by doing. First multiply 105 by 100 and then divide the product by 100. So we would change the problem to 100 times the problem and then divide in the end the product we got by 100. Okay, let's see. Question, can we do without multiplication and division? Okay, yes we can. Okay, let's see what we can do. In that case, tread carefully and don't step over the hidden zeros on the right. Okay, let's see what I mean by that. Okay? In computing deviations, align deviation to the left. So when there's smaller base like here, so it's a 0.5 is the deviation from plus 0.5 from 100. You align that to the left. Okay, let's continue. In cross applying deviation, okay, when we would cross apply plus 0.5 to 9998, you as if there was zeros on the right. So we're going to add 0.5 to 99 here. Okay? To zeros on, treat as if there are zeros on the right. Okay. Finally, you can drop your guard and multiply vertically without worrying about the position. Okay. Number of digits on the right is number of zeros in the small base number. Okay. So because of this manipulation here, that because we didn't have zeros, real zeros to the right of plus 5, and we multiplied without the extra zeros, so we have a fewer digits on the right. Number of digits on the right is equal to number of zeros in this smaller base number. Okay, let's continue with our method. We just and you can refer to teacher's manual for examples of this method. Teacher's manual uses this method. Okay, and continue with the operations here. It's 9998 times 105. Okay. So first we change the problem to 9998 times 10500, which is we have multiplied by 100, and base for both of these operands is 10,000. Okay, let's continue. Deviation 1 is 9998 minus 10,000, which is 2 minus 2, and we had 3 zeros. We're trying to get 10,000 has 4 zeros, and we're trying to keep the deviations to 4 digits. Okay, deviation 2 is 0500, same way, 4 digits. 10500 minus 10,000 is 0500. Okay, let's continue. Cross applied for the left 10500, which is the, and we say minus 2. Okay, so we're trying to do a second operand and first deviation, and operation is minus 10500 minus 002, which is 10498. Let's continue. Do the right part. Right part is multiply vertically on the right, and the two deviations are minus 002 and 0500, which when you multiply together is minus 1000. We have 4 digits on the right and is negative. Okay, let's continue here. So if we add and subtract 10,000, which is 10,000 added and 10,000 subtracted, we got a 1 bar and 9,000. So 10,000 is negative and 9,000 is positive. Okay, so let's continue here. So we can keep 4 digits on the right. So this fifth digit, leftmost digit, which is -1, we would carry to the left. So left become 10498 minus 1, which is 10497. Okay, the answer product so far is left and right. Left on the part on left and right part on right. So which is 10497. This is left here, and right was 9,000 here. Okay, so 9,000. Now we go divide by 100 to get 9998 times 105, which is these two zeros would disappear in division, so become 10497 and 90. 10497 and 90. Okay, let's continue here. There's some references here, and our teacher's manual is my main reference. Tirthaji uses this method in chapter 1, and Glover's book, Vandana's book, and Bhatia's book, they all have sections on base multiplications. Okay?